Hi everyone, are you able to hear me clearly? All right. Just give me a second. I'm trying to fix certain things. All right. So great, great. So are you able to see my screen and hear my voice clearly? Okay, good, good. So, all right. So almost everybody is able to hear me clearly and see the screen clearly. All right. All right. So all right. Do you have any questions before we move forward? Okay. I'm going through your questions. So, all right. All right. All right. So there are quite a few questions. Let me answer those and then we will move ahead with our usual discussion. Okay. All right. Let me take your question one by one. These are very great set of questions. And all right. All right. Okay. So my slides are here. All right. Sure. Sure. Let me copy the questions because there are quite a few questions and I would like to focus on each one as we talk. Okay. So the first question was, all right. First question is from here. I have a couple of questions on Hive. And okay, let me uh, keep them together. And okay, all right. So okay, let me try to answer your questions, and then we will go ahead with the rest of the discussion. All right. So the recording has been started, I hope. Yes, recording is started. So first question is, how do you load data from Hive to Hive from HDFS without removing the source file? Okay, a quick question, quick answer is there that the data is basically moved, right? So the general way is that you copy the data, make a copy of the data, and then you load it. Because whether you are making, no matter how you load the data from HDFS, the general strategy which Hive uses is to move the data and not copy the data. Okay, so there is the load command as such does not provide any functionality to retain the source copy. Okay, we can take a look at load Hive command. Okay, and I'm not sure if it provides you the it provides you any syntax. You can see that it has a keyword for overwriting. That's a optional, and then there are definition of partitions. Okay, so but there is no syntax to retain the source file. So there is no other way than uh, than you having to copy the data by yourself. Okay, so you have to copy the data. Okay, this question is, I also noticed location option will load. Okay, so this is the path from where we are loading the data and so on. All right, let me take a look at the standard Hive grammar that should give you the correct idea. Okay, so if you take a look at, say, load, all right, yeah, you can see that this is the standard syntax. All right, so there is I mean there is no location. Location is the location from where you are loading the file. All right, now the location option was in the create table. When you create a table, either you can let Hive put your tables home directory, tables corresponding directory in the HDFS, or you can specify by yourself. But remember, in case your table is managed and you drop the table, the location of the file, location of the table will be dropped. Okay, so if you drop the table, all the data at the table's location will be deleted. All right, good questions, good question. These are the genuine questions. When you try to do things, these are the genuine questions you will come up with. Okay, now how to delete rows in Hive Hadoop database? Good question. So if you are creating a table based on, so generally the table is on plain text file, and by default, the tables are kind of not modifiable. But recently, because of recent changes in Hive, they have started providing the RC file option, whereby the data is stored in non-plain format, in which the data can be, records can be altered. If you store data in plain text file, it's difficult to delete a particular row, because in a plain text file, If you delete a particular line, you know what happens inside it. When you open a file in a text editor and delete a particular line, and then you press Control S, so the whole file is rewritten. In the same manner, if you delete a row from a table in Hive, it will generally uh, lead to the rewriting of the file. And therefore, Hive was not providing the option to delete files, option to delete records. Therefore, they came up with an idea called RC file. Therefore, they came up with an idea called RC file. They call it RC file, and there are some more formats to store data, and that I have discussed in one of the videos. Then you can take a look at it. So basically, it is possible to alter the table, insert the row, or edit the rows if the table is in the form of RC file. Okay, you can take a look in detail. All right. Next question is, given 1 petabyte of data to migrate into Hadoop, mention what are the factors to be considered for migration and list out the tasks that are involved. Very good question. Very good question. So this is something you will face either in interview or in real life if somebody asks you. And okay, so let's try to see a couple of things. Let me also log in into Cloud Lab as we discuss this in detail. Okay, is question clear to everybody? This is a question from Dheeraj. Okay, it's a question from Dheer, and I hope the question is clear. So let's say you have a petabyte of data to migrate to Apache Hadoop, and then you have to come up with a strategy that copies the data. Okay. Okay. Good. Good, Jayaprakash. Good. All right. Let me try to answer your question. Okay. The next question, I'll take it after this. Yes. Thank you, Jayaprakash. Yes, that is one of the options. Let me try to log in from my account. Okay. Okay. So let me log into my console, or maybe I can log in from SSH. Okay. All right. So I have logged in into my console at E. You can log in into your console. All right. So if you take a look at Hadoop command, there is something called dist cp. Okay. So we have talked about FS. We have talked about jar. FS is for interacting with file system. Jar is for interacting with the jar file. The MapReduce. This CP is quite important. This CP is quite important. Let me try to answer this. This CP, MapReduce, and Flume. Okay. Not Flume, we will say Scoop. All right. So it's a very good question, Dheer. So everybody should pay attention to it. The question when somebody asks me that, hey, we need We have got some petabyte of data to migrate to Apache Hadoop. Mention what are the factors for migration and list out the tasks that are involved. Okay. Now, the first thing you should ask in return is first, find out what kind of data are we talking about? Is all the data is in the form of file? Do we want to put the data in HBase or any other database? Are we, okay, so get the details about the sources. Okay, get the details about sources, as in, is the data in file system or databases or some other network databases, network file systems. Although, I mean, file system contains all kinds of file system, NetApp, and say NFS, network file system, and so on. Similarly, databases, whether it's MySQL and so on. So there are quite various kinds of sources. Next is you need to understand, is the data going to be continuously pumped into the system? Okay, that's another question. Third is, third question that you need to ask in this scenario is that what kind of format are we talking about? Okay, are there very small files? Fourth, the various understanding of various formats, okay, this is something low priority, but it's good to know about the formats, right? So this is something, kind of have a broad level understanding of the source of the data. You need to find out what kind of file systems are there, what kind of input are we copying data from databases, or is the data going to be continuously pumped into the system? Are there very small files? And understanding of various formats. Now, how do these factors impact our decision making? Okay. Now, first one is, let's say your data is in databases. Okay, your data is in databases. Then you use tools like Scoop to copy the data from databases. All right, Scoop into Hive. Okay, I'll show you that today or tomorrow, how to copy this. Yes, Michelle, the recording is on. The next thing is, let's say you're copying from the file system. If you're copying from the file system, you will ask the question that, hey, are there very small files? Are there very small files? Let me restructure my thought process. Okay, so this is something like second level. So are there very small files? If the answer is yes, okay, if the answer is yes, use, okay, create the archives. Okay. Yes, create the archives and convert those into, again, sequence files. We call them sequence files. All right, convert those into sequence files. There are standard tools available for doing this. Okay, standard tools available for converting those into sequence file. All right, then are there very small files, say binary files or any other format files? Then you can, are there very many very small files. Okay, who can tell me why are we doing this? Anybody? Thank you, Jayaprakash. Okay, we are doing two things. One, create the archive and then convert those into sequence file and push that file into HDFS. Okay, why are we doing this? Can anybody help me understand this? Perfect, perfect. Thank you, Jayaprakash. Yes, to reduce the metadata in the name node. Now, question is, what if we created zip file instead of creating sequence files? There is a format called sequence file format. What if we only created zip file or tar file and not the sequence file? Yes. Mhm. If there are many small files, the general strategy is to bundle them into a single file so that metadata is consumed is very less. Okay. Now, the next important thing that you need to do is create sequence file out of the archive file. Okay. Or there are tools to directly create sequence file format. Just like zip file, there is a sequence file format. All right, as we had discussed earlier, that if it's a zip file, imagine there is a file of say 200 gigabyte, right? And if there is a single file of 200 gigabyte and we have zipped it and put it in HDFS, okay? So there is a single file, but this single file contains many small files, and this 200 gigabyte will have around 200 into 8, that is 1600 blocks, right? Now this huge 200 GB file will have 16, okay, so what am I talking about? 200 gigabyte would have how many blocks? 200 into 8, these many blocks, because 1 GB has around 8 blocks, okay? So it'll have 1600 blocks, correct? Is everybody with me on this? Now, if this archive is in a normal zip format, you will have to bring all of the data together. Only then you will be able to uncompress it. What does it mean? In a simple words, in very simple words, it means the data need to be brought on single machine to uncompress. The zip file format is not splittable. Okay, there's a decent amount of research that has gone into creating a file format which is splittable, and sequence file format turns out to be very good. Okay, or the parakeet format. Okay, there are some more formats which we'll discuss while we discuss Spark. Okay, so we'll talk about those file formats to to understand to understand the various kinds of scenarios. Okay, so basically, in in order to process humongous data, instead of bringing all the data on a single node and then uncompressing it and unzipping it, we can use sequence file format and still run MapReduce in a very seamless manner. Okay, so that is the idea behind the sequence file. Okay, so that's one aspect of the problem. The next question that you should ask in this scenario is the data going to be continuously pumped into the system? Okay, is the data going to be continuously pumped into the system? If yes, Let us say you have, let's take a case of e-commerce company such as Amazon. There, all the web servers are producing the logs, the various kinds of data locally on their host. This data needs to be taken continuously from all the hosts. In those cases, you use Flume. Okay, we'll show you a couple of examples of using Flume, and then understanding the format. So this is something low priority, which we can delegate till the point of, say, at later point of view. Okay. Now, with respect to tools, what kind of tools do you use in all of these scenarios? So this is kind of, okay, this is kind of, the general understanding. So you break it down into various locations, because when you talk about the entire organization's data, you will have huge uh, different kind of locations. So you build a kind of a detailed spreadsheet whereby let everybody fill in the data, and then you chalk out the strategy. Okay. Once you are done with it, you might like to use the various tools. All right. Let us say you already have one Hadoop system. Let us say you already had an older Hadoop system in which there was some data and you want to consolidate it. Okay, in those cases you could use distcp. Okay, this is for from one cluster to another. Okay, for copying the data from one cluster to another, you could use distcp. Okay, then usual usual Hadoop fs copy. Okay, put, get, copy. Okay, copy from or to local, and so on. And the next thing is, in case you want to copy from database, you could use Scoop. We will go into the detail. And most importantly, you could take advantage of MapReduce. All right, how would you take advantage of MapReduce? Let us say you have many sources of data, network file systems, and you want to copy that data into HDFS, right? So like I had said, that any MapReduce program is essentially a program which can do anything. It can access a file system, it can access a database. If you look at Scoop, for example, internally it is a MapReduce job. Okay, so they have, some people have written the MapReduce job so that you don't have to write the MapReduce job for copying data from databases. In case you're copying data from say network file systems, in those cases you could use a MapReduce streaming job to copy the data. The input is going to be all the input locations of your data, and then it is going to have only the mapper. So if you are planning a MapReduce, so the input is going to be, input file is going to be the list of locations. Okay, and it will be a mapper only code, and inside mapper, inside each mapper, you would like to copy only some data. Okay, so now here it's a very important part. What is it that we are trying to do here? So even for copying data into HDFS, you can use MapReduce. And the advantage of doing this is you are essentially doing a very resilient, a very distributed work. Okay, you created the list of file locations which you want to copy from data from, and then you created a mapper process whereby the input file is split across multiple map tasks. Some Files are being copied by one map task, some files are being copied from another map task. So this is a general strategy how people migrate humongous data into Hadoop. All right. Jaiprakash's question is, can you justify why we have to use Flume for continuous pumping into system and others not? Okay, so Flume is a very interesting tool. Okay, and when you think about data, there are two kinds of data. One which is silently stored, other which is moving. And processing the two data sets is drastically different. Okay, these are another science in itself. So the work which I did at Amazon, for example, in my before Novik Data. So what we did was we basically created a tool which will continuously process the data. Okay, so when a data is continuously coming, your machinery has to keep running all the time. Okay, so there are two kinds of, generally whenever we think about moving the data or churning the data, there are two kinds of processes. One, batch wise, or you can say on demand, that you ran the process, it did some work, and then it shut down, it ends, the process ends deterministically. Now there are second kind of process whereby the data is continuously coming in, and the process is life, and the process is uh, the whole way of execution depends upon the data. If data is not coming, let's say the data is not being produced for time being, so the process will wait till there is no data. As soon as the data starts coming, process starts executing. Again, if the data is not coming, process sleeps, and then so this process never ends. It never exists. It continuously runs as if it's a server. Therefore, the Flume is the one for unbounded data set. Unbounded data set meaning the data that doesn't end. It continuously comes in. For example, the logs that are getting accumulated uh, at a web server, and we need to day in, day out, 365 days, we have to continuously bring those logs at a central location. In those cases, those kind of data sets are called unbounded data set, and Flume kind of tools are used in these scenarios. Do I make sense to you? Okay, great. And all right, so is everybody with me, or have I lost you? Am I lost in my own thoughts somewhere? Okay, so Jayaprakash had some questions which I did not answer, and there was one more question from Dheer that I'll answer in a minute. Now, Jayaprakash's question was, if something network failure happens during migration, it will start migration from that point itself. The answer is no. Okay, it's a very good question. All right, and so again, why am I focusing so much of time answering these questions? I'll so a few days, I mean, okay, so a few years back, actually, in 2012, at my time with InMobi, I visited Yahoo that time, and I was amazed at the point that they had a team of 100 people, okay, who do the data migration, even in the companies like Yahoo. All right, there was this humongous team whose role was, it is called transportation. Okay, transportation team. Okay, and when we looked at it, we basically realized that we at InMobi also need to form this kind of bigger team. Although we had few people doing it, but then uh, we, I mean, we also got inspired, and at in movie we got a great team afterwards. So this, since transportation is a big challenge in case of data, if you try to move the data, you will realize that it's actually a decent amount of challenge. For example, I mean, in theory, things are great, but in real life, these are the problems like network failure. These kind of failures basically change your whole thought process. Okay, so let me try to answer this question. Now, main question is, if network failures, what happens? So the way you build all your programs, all the copying strategy, whatever copying strategy you build, they should be idempotent. Idempotent. Okay. What does it mean? What does it mean? It means that no matter how many times a command runs, okay, it should not lead to something wrong. Okay. For example, you were copying music from A folder to B folder. Okay. And while you were copying the data or this music from A folder to B folder, and something happened in between. So if you restart the process of copying uh, the data from A to B, it is again going to, prompt you with various kind of question. Should I overwrite it? Should I rename it? Should I recopy it? What should I do? Okay, so let me ask you very simple question with respect to the network failure. It's a very important question. Your data is hardly, say, your music is hardly, say, 4 GB music. You're copying from one folder to another. The only problem is the network is flaky between folder A and folder B. Okay, how do you copy? Can you explain? Who can answer me this question quickly? Okay, let me make it a little more complicated. Machine 1, 2. Okay, yes, who can answer this question? If it's a very simple question, we do it all the time. Copy music from A folder on a machine 1 to B on machine 2. Okay, FTP, SCP, what else? Okay, Kamal says Hadoop is CP. Okay, that's good if we have the music on the HDFS. Okay, all right, good, Christine and Jayaprakash. Anything else? Yes, Hank. I mean, all of you are from IT, and I'm sure you must have copied music. I'm not questioning that it's piracy, but yeah. So good, good. I have got the best answer so far. Okay, okay, great. All right. Sandeep says rsync. Wonderful. And Kamal says SFTP. WinSCP. All right. Now, question to all of you is, we have given so many answers here. We could use these tools. Wonderful. Yes, we can use that. FileZilla. FileZilla is Kamal. FileZilla is nothing but SFTP and FTP. Good, good. Now, question here is that with FileZilla, you can resume the process. Okay. Then there is Xcopy. Yes. And good. All right. Now, if we copy from A folder to B folder, from machine 1 to machine 2, okay, which of these processes can be resumed from the point where you lost the connection? There is a connectivity between machine 1 and machine 2. And imagine that the network is very flaky. It keeps dropping all the time. So what tool will you use in the cases? Okay. Which one of these are easily resumable? So FTP is not resumable because you will have to either overwrite or skip, and it can't figure out that these partial copying of music has finished. Okay. Then SCP. Okay. SCP also is not. Xcopy is not. Out of all of these solutions, I find rsync to be the most reliable. Okay, what does rsync do is it does a very clever way of copying file between two servers. It's a very clever way of copying files between two servers. It figures out what data has been already copied and it synchronizes only the changes. Okay, so take a look at rsync. So all I'm trying to say is whenever we are copying the data from one place to another, we build a script in a way that even if it executes 1,000 times, it should not lead to corruption of the data and recopying the data. Okay, even if it's overwriting it, it will keep on consuming the network bandwidth and the time. Okay, so we always build a script which, no matter how many times it executes, the end state of the system is same. Okay, that's called idempotent. Idempotent means no matter how many times you apply a function, the end result is same. Okay. Yes, Jayaprakash, that's correct. So we always, whenever we are building kind of strategy to copy the data, we build the programs which are idempotent in nature, meaning even if you remember we talked about the greedy way of what do you call, there was a term which we discussed in yarn, whereby we were re-executing a program in case a program is slow. We were re-executing on second machine. Okay, so if your process is not idempotent, it might lead to corruption of the data. So no matter what you do while copying this 1 terabyte data, 1 petabyte data, make sure the end result should be correct. Okay, in those cases we find that the rsync process to be important. Yes, that's correct, Kamal. We talked about the speculative execution. In speculative execution, we basically spawn the spawn a second process. All right. So yes. So important part is that's another point I wanted to make is one, understand your data. Second, utilize distributed network, meaning MapReduce, scoop flume. Third, make sure that when you're building your MapReduce or you stream MapReduce streaming, Hadoop streaming we call it, then we build all the script in a way that they are resumable. Okay, they are resumable. For example, we talked about, out of this I found, I'm not sure about network NDM, I've not used it. Maybe that's resumable, but rsync is kind of resumable. All right. All right, it leads, no matter how many times you copy the data, it will lead to the same full the end result. Okay. All right, so that's about it. For example, if you're committing your source code, no matter how many times you commit, the end result is going to be same. Okay, without changing. If you're continuously only committing, you will only get the same result. Meaning, when you retry things, it should not create a corruption of the data. All right, so that was our discussion on the transportation, and these are very important points, so keep these in mind if somebody asks you about this. Next question is from Shashi, that what tools do you use for data sanity check? Okay, so yes, so I'll check So Hadoop FS provides you a way of computing the MD5 checksum. I'll tell you. Okay. So as far as I had used it earlier, yeah. So you can see that. All right. A question from Shashi is that, let's say you copied certain data into Hadoop. All right. Now your question is that I want to check whether the data was copied correctly or not. Okay. So what you do is you compute the checksum locally and you use Hadoop FS checksum. All right. And this will, and then compare the checksum. So what is checksum? Checksum is a signature of the data, which is difficult to tamper with. Okay. Difficult to recreate from the data. Okay. So, but since checksum is generally a very small string, all right, therefore it's easier to compare. It's a signature of a big file. So you could basically do is, let's say you have a local file, compute the MD5 checksum locally using MD5 sum. Locally, you can see, all right. So you could see MD5 sum of a local file and run the copied one and then compare the two. That could be easier. All right. A question from Michelle is that, okay, I missed one more question. Yes, Hari, that's a very good point. So end state is same even in the HTTP put or get. That's correct. REST-based interfaces are designed in a way that no matter how many times you execute get, you get only the same thing. Okay. All right. Now a question from Michelle is that no, from Jayaprakash, will Scoop or Flume tell us the progress of migration? Yes. The MapReduce API provides the progress. Okay. And Flume as well as Scoop both tell you the progress. All right. Now a question here is from Michelle. If there is really bad problem, is there a way to back out changes you made to the data? All right. All right. So it's a difficult question to answer. So, okay. So question is that, does HDFS provide you kind of a transaction log whereby if you made some goof up, you could revert back to the previous version, correct? The answer is no. HDFS doesn't provide you a way of keeping the history of a file. Instead, it provides you with on the user level, it provides you just the basic thing. So the way these kind of systems are built is based on your requirements. You upload your data or make your changes in a temporary folder, create your own temporary folder, and then once everything is successful, you can happily move it. Okay. And in case you want the editing of the data to be very frequent by many people concurrently, in those cases you use a NoSQL database. Okay. Good. I hope I have been able to answer the questions so far. All right. Hari's question is he's not able to solve the second problem. Okay. Okay. So this one. All right. All right. So, okay. Let me answer your question there in a minute. All right. I hope I was able to answer your questions related to moving data. Is everybody clear on whatever we have discussed about copying the massive amount of data? All right, all right, all right. Great, great. So now coming back to the next question. Okay. So next question which people are facing is with respect to the greater than 30 ratings. Okay, greater than 30 ratings. So yeah, there are two ways to solve it. If you have read, okay, I'll give you two hints. Number one, okay. So we were, all right. Okay, okay. So let me try to answer this question. All right. There are quite a few good questions. So, all right, let me focus on the current one. All right, so here the question which we are talking about is the hive one. And the hive, where is the, all right. So the second one is probably the more difficult question. Is everybody able to do the first question? Yes. For each movie, how many users voted for it? Correct? That was the question. So let me also, all right. So where is my hive? Hive will be more friendly. Hue as in, okay, okay. We'll check your answer, Hank. Okay. So where is the, all right. So this was the last query which we had executed. You can see that. Now, if we have to say find, what was the, this is the query, right? For each movie, how many users voted? All you have to do is use the group by. Okay, use group by for this. Okay, use group by on movie ID. Okay, movie ID. Now for the next question, I was assuming that it's more of a SQL test. Okay, for movies having more than 30 IDs. Yes, thank you, Pankaj, for helping me out here. Yes, this is the right way of doing it. Either using this, okay. So this is what do you say? This is something called subquery. Okay, so he has created a subquery here. You can see select movie ID from this where count star is this, right? After grouping, it did the count star and greater than 30. correct? And yes, and then all right, this is not okay. So I'll have to, I'll give you the correct answer. So this is the kind of example which you can use here. Okay, this is a kind of example that you can use, although this is not very optimal, but it can be used. Okay, the other would be, all right, let me see who else. Yes, that's also correct. This one is correct. All right. No, count rating is not wrong. I mean, okay, because this, okay. Count, any, as in you could also use count star. It doesn't matter. Okay, basically we are trying to count number of people in each movie ID, right? That's why he has put count rating. You could also say count star. Okay, so this looks okay. I'll have to take a look at exactly, maybe you'll have to make a little bit fine tuning, but the theme of the answers is actually this. The other thing is you could use another table. Okay, another table. You could select blah 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 into another table, and then use that another table to filter out the data. Okay, so okay, so this is a kind of inspiration you can deduce, because this is something which we did as part of SQL tests. Okay, yes, you could use another table or a view. Thank you, Kamal. Or a view. Okay, so the best answer from my point of view is use view. All right, use view. That is generally far more effective and also simplified. So there are three ways. One is by using subquery. Okay, second is by using this count and having this way. This looks okay to me. Okay, so for each movie we computed the ratings, average rating, as well as we computed count, and we filter it out using a having clause. This actually works. I just need to check why it's not working. This actually works. Okay, and the best answer would be you use view. You first define this part as a view. Okay, and then you join that view with the movie table, and then do the computation. Yes, Hive supports subquery. All right, Hank, you want to give it a little bit more try? This is a very important aspect, because this will force you into learning SQL a little bit more deeper. Okay, because 90% of the work still happens using SQL when it comes to big data journey. Okay, so Hive is kind of unavoidable and is quite important when it comes to analyzing even huge data. Okay, all right, good time to move ahead. Okay, question from Hank to everyone. Um, the PyHive and Hive SQL differences. I'll have to take a look at it. Okay, this is something I'll just move to my to-do. All right, I will move it to to-do. Okay, so I don't have a pre-prepared answer for this. I'll have to study it a bit and then I can tell you. All right, though I have used HiveQL earlier, but I haven't used HiveQL is what we are using, but I'm not sure about PyHive so far. Okay, and yes. Okay, so the other question is from Jayaprakash. Can we have a practical session on data migration? Yes, we can have. Let me move to do. Basically, once we finish our most of these analyzing data part, then we can, at the end, we can have one practical session. Let me prepare data for it. Okay, so this is again a to do for me. I will try to prepare that part, and then we will do that at the end of the course, maybe in a separate time, because um, the class is going to be next class is going to be postponed. So I'm trying to see if we can do it on a separate timing. All right. Then a question from Harsh is how to pick two adjacent words for recommendation engine for of problem two. Okay, so Harsh, I would suggest you something. You take a look at one of the people who have done the assignment. Okay, so all right, there are quite a few answers. Let me show you some of those. All right, you take a look at this one. All right, I've written the code for this. Take a look at it. If you are not comfortable, we can discuss it in detail. All right. Great, great. Now, there are a few more questions. Great, Jayaprakash. I would love to have a look at your solution. Okay. One quick question is, so if we have a Hive to store data in the table format coming from files, then HBase. So Hive is good to store data which is editable. Sometimes these days they have started providing a way to edit data, but HBase is great for, okay, let me give HBase, great for billions of rows and millions of columns. Okay, none of the systems can compete with HBase with that. All right. This is the quickest answer I can give you. All right. Did I miss anybody's question so far? Now I think I have more brother to answer. Okay, great. So where were we till the last session? We were talking about NoSQL. All right, great, great. Let me, these were today were wonderful set of questions. And yeah, one question I missed was this. Okay. Yes. Question was create external table movies, movie ID, title, genres, and row format delimited by column and so on. Title is not populating. Okay. All right. Let me see. All right. Okay, so you know what I'll do, Dheer? Just send me a separate mail. I'll take a look at separately. I think that'll be better because I'm suspecting that there are two columns in the file. That's why first column movie ID, but second column became empty, and third column afterwards became genres. Okay, let me take a look at it. Yeah, you can see that. Yes, see, there are double columns. That's why there is the empty file. Okay. So what you can do is you can just put a dummy. You can say, here, blank column, and that's it, and so on. I think that should do. Okay. Did you try this one? Did you put? Okay, try this one. I think this should work because it is terminating the field by column, and therefore, since our data is in this format, okay, therefore you need to skip one of the columns. So this is the first column, then second column is blank, third column is the name, fourth column is blank, and fifth column. Okay, and you can anyway, those fields would be ignored happily. Okay, so generally field termination is a single character. I'm not sure if double character works. Therefore, it's better to use this strategy. All right. All right. A question from I'll ping you this one. Okay, so I've left everything as such except for this one, except for this part. All right, I just added 2 more columns to it. Question, a very good question from Jayaprakash. Any libraries there are to process video file and store it? Okay. So again, with respect to video files, generally video files are stored as normal files, big files, and so the standard tools whatever you use for video processing can be used as such with the MapReduce process. Okay, same library whatever you have used in Java for processing a video file is good enough. And what I use personally, okay, so for example, these videos which we are recording right now, I used something called MoviePy. Okay, it's called MoviePy library from Python for processing these videos. Okay, I wanted to extract the text out of these things so that I can understand my intonation problems. So I used MoviePy to extract the subtitle, the text, the voice to text from my videos. That time I was using MoviePy. Also to remove silences from my videos, I had used MoviePy. Okay. A question from Kamal. What are RC and ORC file format to store the file and the differences? Okay. So the question is going to be tough to answer here. Okay. All right. So RC and ORC file formats to store file are basically both of these are competitors. RC file came first and then ORC file. ORC file is little more optimized. We can discuss in detail. Maybe I can take it up as a separate question. All right, I can answer you separately. All right. So basically, these are the various file formats, competing file formats, and afterwards there are a few more file formats have come in which are better than these as well. Okay. So in general, why do you use these files is so that if you have lots of binary files or lots of files that you want to process, you want to store in HDFS, you combine them and put them in these formats. These files have very interesting structure. In the header of these file formats, we have the information about the record markers, that this row is starting at this byte, this record is starting at this byte. So these file formats are a file system inside itself. Okay, the way you have a file system which has a, like in case of a MS-DOS, you have file allocation table. File allocation table keeps track of which file is is at what location in the disk. Similarly, ORC file formats, the header, the beginning few bytes, store the information about the location of various markers in the file. All right, and that's how it is very much possible. And these files have something called padding in them, so that you can edit the records in place without having to save the whole data again. You can write partial data without having to rewrite the whole file. That is the advantage. That's the advantage of using these file formats. Do I make sense to you, Kamal? All right, good. Great set of questions today. And I think you should continue this kind of questioning during the week as well. All right. And yes, okay. Stay a little bit more active on the either Facebook group or the WhatsApp group. I'll prefer the Facebook group because I find it difficult to type on the phone. Okay, so keep asking these questions, and that makes everybody a little bit more active. All right, so where were we? So we talked about cap theorem. Everybody got the cap theorem? Okay, I think we were about to start cap theorem. All right, great. So let's jump in. This is a very interesting point, and I've done a good job at studying it again and again. And so long back when I was trying to build my own company, it was a kind of a database which I built. Okay. All right. So I think we completed this one, right? No? No. Ouch. I think, yes, you are right. I was completing this one, right? I was completing this one. I was here. Yes. All right. So let's jump in. All right. So in the last session, we had discussed about a typical story of 2000s. Typical story was that we got this great idea, we built a product, we made a public launch, and then the service became popular. We implemented cache, cache as in the memcached, in which we have everything in place. And the moment we brought in the cache, it was no longer consistent. Then the service still grew popular, and then we implemented a high-end machine. We bought a really high-end machine because we got some amount of money as a funding. But then the features started growing, and as features started growing, there were too many tables, and hence we had to denormalize. Okay, we have too many tables and therefore too many joins on every query. Whenever somebody asked for a page, we had to combine so many features and give the user the entire page. So we had to denormalize so that all data is in a single table and so on. Now, still it did not stop there. So we stopped using server-side computation, and then we kept on pre-materializing. Pre-materializing is pre-preparing the cache, not on demand, instead pre-preparing it. And we stopped joining and avoiding complex queries because of the load. And then we dropped secondary indexes and the triggers. Okay. Uh, and that, you know, if you take a look at what we did, we removed all the features for which we bought the database, and still it did not work out. Even after doing all of this, you know, going back to kind of a Buddha way, I mean, leaving the whole feature set because of so many requests coming in, still we could not solve it using single machine. That's where NoSQL came in. Using in NoSQL, the general idea is to use many machines to provide our database. And when we provide, when we have a database on using NoSQL, when we have a NoSQL kind of database, which is running a single database running on many machines, we need to identify uniquely every record. Why? Right? Because imagine your data to be broken. Imagine you have a table which has 1500 records, and there are 15 machines, each machine having 100 records each. Okay, but it's a single table. Now, to keep track of which data is where, which row or which record is where, we need to have an identifier for the record, right? Even in the memory, like the way we have RAM, we basically have an address for every memory. That's how we are able to divide the data in the memory, correct? So NoSQLs basically keep a identifier for every record. The definition of every record is very much dependent on various kinds of databases. Okay, there are quite a few NoSQL databases in the market, and these are a few examples. And the definition of record or a row varies from database to database. Like, for example, the HBase which we'll study, it is very much similar to your relational database. It has a big row containing column values. Okay, we'll go into more details. Then there are these databases called like MongoDB. Okay, they are document-oriented database in which a record is a huge JSON object. A record is a huge JSON object, and this JSON object could go up to few gigabytes. Okay, so and it could have many labels in of the structure could be complex. The way you have XML, tags inside tags inside tags and so on. Like you have a page in which there is a div inside div inside div. Similarly, in JSON as well, you can have object inside object inside object. Okay, so that's document oriented database. The way you have HTML page containing tags inside tags inside tags, that's a document. Okay, the document is a complex structure of the data inside data. Okay, it's a kind of hierarchical storage in itself. Every record is complex data. Then we have key value. Key is, these are the most basic form of databases. This is where the whole story of NoSQL begin, whereby there is key and there is value. There is key, there is value. Key is unique and value is there. Okay, key is unique and there's a value. Value could be binary or plain text. Okay, so Redis provides you the value to be complex and so on. So then there is graph database. These are new kind of database, and this is used for Facebook kind of requirement, whereby we have to store humongous graph using many computers. Okay, the next is SQL versus the NoSQL summary. I mean, here there is not much of the information. So the most important part to understand is that in NoSQL, you don't have luxury of SQL because it doesn't generally have joins. It doesn't have primary secondary relationships. It doesn't have the row structure consistently. the query varies. For example, so while SQL databases started in 1970s, NoSQL started in 2000s. The There are minor variation of in case of SQL database, everybody follows the standard SQL. If you had read the CORDS principle, they follow the standard RDBMS principles. But in case of NoSQL, there are many different databases. There's MongoDB, there is HBase, there are so many of those. Okay, there are around 200 of those. Okay. The data storage model in case of SQL database is relational. In case of NoSQL, it varies. In SQL, there was structure. There was structure that the data has to be in the column format, and there was strict rules about it. That's not there in the NoSQLs. Okay, most of these databases are most of these NoSQL databases are open source. Okay, why is it open source? Because let me tell you about my experience. So with T-Bits, with my previous company before Amazon, before InMobi, we built this kind of a document management system. It is essentially a kind of a database for many people. So people uploaded data into this. Now, people have a fear of a vendor lock-in. When we went for sales pitch, when I went to for sales pitch to various companies, they said that our data is going to get logged in into your system, and therefore we can't trust you. And it was a very tough call for us. So we did all kinds of things like signing a contract with them that in case a company goes down, we will give you the whole source code, this and that. But out of all of these, we found that opening the source code to the companies was the only way to build trust in us, so that in case they have this peace of mind, in case this company, tomorrow if we become a little greedy and start saying that now you pay us few crores more or few million more, then they will say that, okay, we have the source code, we will hire some more developers and get our data out. Okay, so open source, that is one of the reasons why any database product, to avoid vendor lock-in, these database products come up with open source kind of models. Okay, and that's one of the reasons why Hadoop or any of these new genre of tools are accepted by the industry. Okay, because open source gives a lot of flexibility. Okay, and so while standard databases support transactions, but NoSQLs don't. Most of NoSQLs provide you the transactions based on record, each record, but not entire table. Okay, we'll talk about it later. Data manipulation in SQL database SQL, while in NoSQL, it is different APIs for different systems. Some of the NoSQLs, such as Cassandra, provide SQL, while MongoDB kind of NoSQLs provide their own language, while HBase kind of systems do not provide any SQL. They provide a simple get-put API. All right. All right. Okay. So Dheer, yes, let me take a look at what is it that's not syncing. A question from Jayaprakash: stored procedures and triggers will be there in NoSQL database? No. None of the NoSQLs is providing that yet, but yeah, I'll answer it a little bit more politically. It depends. Okay. Some of the tools, after a pressure from the industry, they've started providing triggers, but not stored procedures yet. Okay. All right. So now, the other thing which we had to understand before jumping into NoSQL is that CAP theorem. CAP theorem says that out of three things, consistency, availability, and partition tolerance, you cannot have more than two. You cannot have all the three. Okay? You cannot have all the three. What does it mean by consistency? If all the nodes in the network see the same data at the same time, that is consistency. Availability, a guarantee that every request will receive a response, whether successful or failed. That is availability. If more the guarantee, more the availability, less the guarantee, less the availability. Okay, so availability is not yes and no, but it's more of higher availability or lower availability. Okay, so next is partition tolerance. In case network goes down or network get splitted up, the cable connection between the two data center, if it is disrupted, can the system operate? If can, that means it is partition tolerant. If cannot, it is not partition tolerant. Okay. So now, out of these three qualities, consistency, availability, and partition tolerant, none of the systems can guarantee all the three. This diagram shows you a better view. Okay, you can see that out of these three, nobody is on the intersection. While there are some databases which are here, some databases which are here, but nobody is in the center. Okay, so this diagram shows you loosely what are those databases. All right. Next is, let's try to understand why is it so. Let's take a look at the three kinds of databases. On the extreme left, you have relational database. Now, a relational database generally runs on a single machine. Okay, generally runs on a single machine, and all the readers and writers are talking to a single machine. Right? Therefore, if a single machine goes down, the neither readers can read nor writers can write. Therefore, it is not available. If there are too many people using this machine, sorry, so there are too many people using this machine, then since it's a single machine, it's going to be, there is going to be a lot of requests coming in on a single machine. Therefore, it is not available, and in case it goes down, the whole process is disrupted. Therefore, it is not partition tolerance. Killing a single machine, if it is I mean, killing a single system, if it is not stopping your data operations, that means your system is partition tolerance. Here it is not. Now, let's take a look at the second architecture. Let's take a look at the second architecture. In the second architecture, this kind of architecture is generally found in MongoDB and Zookeeper and others, is that there are two kinds of systems. There is one which is master, and then there are rest. Users write to the master while others read while readers read from all the machines. Okay, so there are many machines in the network which are providing the read, while there is only one machine from which only one machine from which all the users are to which all the writers are writing. Okay, so writers are writing to A, readers are reading from B. This is good because you have increased your ability to cater to people. That means it is available. If A goes down, there is B. If B goes down, there is A. That means it is partition tolerance, and hence it provides A and B. But imagine that you just wrote the data to A and you are trying to read, and your request went to B. You will get the older data and you will cry saying that my data is not written. That means the database is inconsistent. All right. So if you think about, if you do not know this structure and you have an API which is writing the data and reading and comparing it, okay, you will find that while writing it says that the data already exists, but while reading I'm not able to find it. Okay, why? Because the change that you made at A is taking some time to reach B. Therefore, therefore, it is not consistent, but it is eventually consistent. In a long run, things are going to be fine. But right now, the records I've saved are not found in B because it is in the transit, in the transportation. Therefore, such kind of systems are not consistent. Instead, they are eventual consistent, eventually consistent. The third one is the third structure. When I thought about all kinds of structures which we have built in past, which are generally built in data centers, I came up with only these three models. Most of the other models are combination of these three. Okay. The third one is where you have a single system receiving all the reads and writes, and there is a backup. Like in case of name node and secondary name node, right? In case name node goes down, we have another one, but all the reads and writes are happening from a single machine. So such kind of systems cannot cater to many users, therefore they are not highly available, but they are partition tolerant as well as consistent. So these are the three general models of any data systems. Okay. So question from Jayaprakash is, there will be like secondary name node kind of for RDBMS? Yes. So most RDBMS also build this kind of system. You build RDBMS with a failover. Okay. They generally resemble this one, but again, these are not highly available. Okay, so most of these systems that you will see would either lie here or here. Okay, either here or here. All right. So Bernie's question is, for RDBMS using Oracle Data Guard and SQL Server, always one on solution, we can achieve high availability. So this is not highly available, this last one. I think, Bernie, in the solution which you are suggesting, that it is basically the last one, right? Primary and secondary. Yeah, this is not highly available because it's only one machine from which reads and write happening. It's just that they have failover. In case A goes down, there is B. It is partition tolerant. It is consistent and partition tolerant. All right. So as you can see from this diagram, that when we try to make system partition tolerant, okay, when we tried to make system partition tolerant, it was no longer consistent. All right, database links will be used between A and B machines. I did not get that part, Jayaprakash. You will see that soon, okay? The next point I would like to make you understand is, okay, 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 okay. Yes. All right. So next point I would like to make you understand is what is difference between column oriented database and row oriented database? This is a very important topic, and you will understand why there are so many formats that you see these days. Okay, but before that, let's take a break for 10 minutes. Okay, break for 10 minutes. Back by 9:46 p.m. IST. Okay, thank you, Christine. All right, see you in 10 minutes. Hi everyone, I am back. So should we start now? All right. All right. All right. Okay. So all right. So we need to understand what does it mean by column oriented database. And so let's take a look at it. Let's say there is a table called which has two columns, employee ID and name, and this file needs to be saved in the disk, right? And this process of saving some data from memory into disk is called serialization. Why we call it serialization? Because the data is kind of serial in a serial, meaning it's a sequence of bytes, right? So we need to convert this table into sequence of bytes, which means you have to figure out a way to break down this table into a single row of text, correct? Now we can do it two ways. One, we can do it actually in many ways. One is that we pick the row and then append the second row afterwards, then third row and fourth row. Right? That's called row oriented, meaning 10, Joe, 12, Mary, 11, Kathy. That's how we store the data. Okay. Next is that we first store the first column and then the second column. That means 10, 12, 11, and then Joe, Mary, Kathy. Although for presentation wise, for the end user, it's still a happy table. It's still a table. It's usual table. But under the hood, the way it is saved, that's what makes the differentiation. That's what decide that I mean that the way it is saved is different for column oriented database. In column oriented database, we first store the column, first column, then second column, while in row oriented database, we first store the first row, then second row and third row. Okay. Now this, this is quite arguable, that why are we doing column oriented way? Why didn't we continue to use row oriented way? In our traditional databases, we always saved the data in a row oriented fashion. Okay, every row keeping the enough space for future data for that row and so on. Okay, and it was quite easy to do that. It was quite easy to store row oriented way. Now few researchers realized, there were certain researchers, they realized that the data can be better saved in the form of column oriented way, so that the compression is better. Compression is better in the sense that, imagine, so how does compression actually work? If you think about it, the way we, where we compress the data is an interesting aspect, right? If you see the music lyrics, for example, and at the end of music, at the end of line, we put dash two, correct? Something and dash two. That means that this line is going to be sung by the singer twice, right? In the prayers, you will find dash two, dash three at the end of the line. That means it has to be repeated, correct? So this way, this is a most primitive way of compression. Instead of writing the same line twice, we are writing it once, right? So exactly with the same philosophy, although in a mathematical way, the compression systems work. Okay, deduplicating the data, giving a symbol to chunk of bytes, and then repeating the symbol instead of repeating the same thing again and again, consuming more data. So figuring out which symbols and how to optimize that, that is decompression. Now, people realize that if they compress the data column wise, it's going to be far more efficient because columns contain similar or same data. Columns contain similar or same data uh, generally. Therefore, the column-oriented databases, the column-oriented compression was far more effective. That is one of the reasoning why column-orientedness came into play. All right. I hope I made sense to you. I answered two questions. Why do we why do we need column oriented database? First, what is a column oriented database? All right. Now, the people at base, they they realized that neither of the systems, okay, neither of the systems were neither row oriented nor column oriented was the solution to the people's problem. So they came up with a very political decision. They came up with something called column family oriented database. All right. What is column family? A column family is a group of columns, and then they basically a column family is stored first, then second column family. So CF1 is stored first, then CF2, and so on. And inside the column family, there could be multiple columns, and those columns will be stored in row-oriented way. Meaning, when this table gets saved, first CF1 will be saved, then CF2. And inside CF1 will be 10 Joe, 12 Mary, 11 Kathy, and then 23, 33, 45. Okay? Is everybody clear about column family oriented database? All right, let me check who all got the idea. All right, now let's take a look at how this strategic column family orientedness makes the difference. Okay, imagine that there's only one column per family, and imagine there is one column family for all the columns. Now, this is okay. So this is okay. Now, if you can see that, is this column oriented or row oriented when this gets stored quickly? When this data gets stored, it will be column oriented or row oriented. In the first one, Michelle says column oriented. Anybody else? Yes, this is column oriented because first column family 1 will get stored, then column family 2 gets stored, and then column family 3. So first this column, then this column, which is essentially column oriented way of storing data. Then column family, in the second table, you can see that all the columns are inside a column family. Therefore, first column family, second column family, third column family. And sorry, these are the three columns inside a single column family. Extremely sorry. So now this data will be stored like 10, 0, 23, and so on. So this will be more like Row oriented or column oriented? Correct. This will be more like row oriented. So the data will get stored here column wise, here row wise. Okay. There were two questions that were waiting for answer. Let me try to answer those. Let me try to answer those questions. Who creates column family and how? It says we as a developer or architect, we create the column family and we mention that. Michelle's question is not sure how would you figure out which columns would be grouped together. Good question, Michelle. So if you have to access or save the same columns again and again, put them in a single column family. Okay. If you have to again and again access and modify the same columns together, you should generally, like for example, first name, second, last name should be generally kept in a single column. Okay. This question is how to differentiate rows in column oriented families. How to differentiate rows in column oriented families. I did not get the question. Hank's question is what facts should be based to divide the columns? So generally the data that you want to access together, you put that data in a single column family. Those columns that contains the data that generally get frequently accessed together, you put them in a single column family. Okay, accessed or updated. Okay, this question is, how do you divide the first row and second row? It all depends on, inside HBase, they are non-printable characters which divide the first row and second row. And you will see more things like putting data from different column families into different folders. Okay. So mostly it is, so we define manually, we define while creating a table, we define in HBase that these are the columns that are required. Okay. We'll see that now. You can either do it from UI or you can do it from the command line, or you can use a program to do both the things. Okay. So you can do it from the console, you can do it from here, you can do it using your program. All right. So this was a quick introduction of NoSQL, although it was not quick, but it is quite essential. All right. Let me remove all of this from here because we have already. All right. So if programmed, what language? Generally Java. In case of HBase, you can talk to HBase using Java. So what is HBase? It is very important to know. HBase is a NoSQL database which provides C and P, consistent and partition tolerant, column family oriented database. Okay. It's based on the architecture of Google's big table to handle billions of rows and millions of columns. Sure. Okay. And it is strongly consistent, not eventually. It provides automatic sharding and it provides the reason servers. All right. And okay. So let me start from the beginning. I think I'm getting a little distracted. All right. So HBase is a database which out of C, A, and P, it is consistent and partition tolerant, which is CP. It is column family oriented database. It is based on Google's big table, designed for hundreds of millions of columns or billions of rows. Okay, in case you have data smaller than that, then you should continue using relational database and do not use HBase or any other NoSQL. If your database is small, do not use HBase. Okay, it is strongly consistent, not eventually, and it provides automatic sharding. Okay, meaning your data gets distributed, divided amongst many servers automatically. There is a failover at every node. We will show you that. It has a strong Hadoop and HDFS integration, and the way to process data is using MapReduce. Okay, using MapReduce or using Hive. Okay, you can process the data using MapReduce or Hive. The API is based on Java and Thrift. It provides Bloom filters and and coprocessors. All right. Now I'll explain what is region server and what does sharding mean. Sharding means dividing the data in. Imagine you have a huge table, cutting the table into sections, and putting it on different machines. That's called sharding. Okay. So the HBase architecture is this. At the lower level is HDFS and Zookeeper. Zookeeper we'll discuss later. And above that, there is master and region servers. HBase contains, again, same architecture as HDFS. There is a master, and then there are many data nodes. Similarly, here, there is master and region servers. Region servers contain the actual data, while the master contains only the pointer to the data. Okay, master only keeps a record of the IDs, that the ID ranging from this to this are on this machine, this region server. IDs ranging from this to this are on that region server. On top of all of this, HBase provides an API. Okay, so you can see what does it mean by region server again. Okay, user comes to the master, master finds out about its region servers through Zookeeper, and then reads the data from Zookeeper and finds out about region servers and talks to them. All right. So the tables are tables inside HBase. When you think about a table, when we are storing table into HBase, they are horizontally sliced into regions. Each region comprises of a subset of table rows, and every region is denoted by the table it belongs to, is first row, last row, and initially when the data starts loading into the system, it is on a single machine. Okay, and then so you came to master and said, hey, I want to create a table. It created a table. Okay, in the beginning it only has one reason. Reason is bunch of rows. Okay, reason is always stored on a single machine. A table contains many reasons. Okay, and reason information about reason is that it always contains a range of IDs. Okay, the data in HBase is ordered by ID. Every row, every record has got an ID. Every record in HBase has got an ID, and reason contains many of these rows, which means to identify reason, you don't need to note down all the IDs. You just need to note down the range. The way on the left side of your dictionary, you will find out that this page contains the words starting from this, ending here, right? The way we identify a page in the dictionary, right? A usual dictionary, I mean the Oxford Dictionary. On the right hand side, you will see that on this page, there are words from here to here. In the similar way, master keeps track of which range of IDs are on which region server. You can always think of HBase master containing a huge index of region servers. And the way to identify region servers is that this page or this region contains ID starting from here to here. Okay, that's how master keeps track of which data is where based on the region server starting and ending. All right, so every region is so tables are automatically partitioned horizontally as in the whole table is cut down into region servers. Each region comprises a set of table rows. Okay, a region is denoted by table it belongs to, the first row inclusive, last row exclusive. Initially, a table comprises a single region. Okay, initially a table contains only one region, and as the data grows, this region keep on splitting into two equal halves. And then when these regions keep on splitting, they keep on getting distributed amongst various machines. Okay, so until the first split, we are only talking to one machine, and after the first split, there will be two regions, which means two machines, and hence we'll be talking to two different machines. Although it's not always guaranteed that two regions of a table will go to two different machines. They could stay on a single machine, but generally it tries to distribute them onto different region servers. So a table is broken down into regions, and regions are distributed across many machines, and as the data grows, number of regions grows, and hence the number of requests are divided onto multiple machines. Okay, so this is the general philosophy of division of data. Okay, Dheer and Swarn, was I able to answer your question? So Jayapraka's question is, what's the difference between Hive and HBase? HBase is a proper data storage, while Hive is more like an analytical engine. It converts your queries into MapReduce and executes. That's Hive, and HBase is proper database. Data, not database, it's a data store. A question from Hank is, how many region servers can be managed by master? So generally, we can increase the size of region server, individual region. The way it basically splits when the data grows beyond certain size. Okay, when the data grows beyond a certain size, it gets splitted, and hence the HBase master generally does not contains too much of metadata in the memory. Therefore, it can handle humongous amount of rows. Okay, humongous amount of data and rows. Okay, so I don't have exact information about the limit. Okay, and the second question is, what happens when master is shut down? In case the HBase master goes down, there is something called secondary HBase master. Exactly same as name node and standby name node, we have HBase and standby HBase. Okay. You can take a look in Ambari, you will see there are two HBase master. All right. Question from Swan, it splits automatically, or we have predefined mentioned the size of the maximum size of a region, and if the size grows beyond that, the region is cut into two equal halves. Okay. Now Pankaj's question is, HBase and HDFS are on different cluster. No. So every machine, as we talked about earlier, right? Every node generally has three things: data node, then node manager from Yarn, and then region server. Okay. What's happening? Yeah. So the every node is generally contains at least these three, because node manager and region server, both region server need to talk to node manager sometimes, because it has to, let's say somebody wants to do a massive computing, parallel computing. In those cases, node manager and let's say somebody is executing MapReduce and they're reading the data from HBase. In that case, node manager will talk to region server, and region server need to read data from data node. Therefore, generally, if you keep all these three together on every machine in the network, the overall performance is going to be really high. All right, great set of questions, very great set of questions. Now moving ahead. So a table, let's say there is a table which contains key and the value. Okay, think about a dictionary in which there are name and meaning, word and the meaning. Word vary from A to Z, okay, A to Z. And if you cut it down into individual pages, okay, it'll look like this. Let's say there is a page that contains all the words starting from A till C. That's the first reason. It goes, let's say it's located here. Then second reason starting from C to F is here, and so on. Also notice the square bracket and round bracket. Round bracket says that the C is not included on this one, while square bracket says that A is included in this reason. So it is A starting with A, including A up to but not including C. Similarly here, from T but before Z. That's what it means. The round bracket means the 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 right hand side does not get included. So Jabrika's question is, HBase will do the partition if data increases? Yes. Automatically, this is called automatic sharding, cutting the data automatically based on the size. Yes. We have to create the keys. HBase will not generate the keys. Whenever we update the data, we have to provide the key. All right. Okay. So the data model is very simple. It contains, it is, so HBase is, whenever you think about HBase, you should think about this. Okay, so that's the general architecture, that whenever you are there is HBase master, there are region servers, and region servers contain the, if you have to store a dictionary, region servers will be storing individual pages, okay, the sections of the whole dictionary, and master will only contain the index of the region servers, keeping track of which range of words are on which region servers, meaning which page is on what machine. Okay, so this is what it looks like. So you can see that this is the logical A to Z, and while it is divided into 6 reasons, and there are only 3 region servers, therefore there are 2 reasons per region server. Okay, so that way when the data is kind of uniformly distributed across the cluster. Okay, next is understanding the data model. Data model understanding is something most important. Even if you have a very vague clue about the underneath, it's still okay. If you're using HBase, it's important to understand the data model. So HBase is nothing but sparse, distributed, persistent, multidimensional sorted map. Now let's go word by word. This is like too heavy definition. So let's go from right to left, meaning the first adjective to the last adjective. So the HBase is a map. What is a map? Map is generally a key value pair collection. Okay, map is generally a key value pair collection. There is key and there is a value. So when you store data into HBase, you are going to give a key and the value. Now it's sorted, meaning the data in this map is sorted. Okay, which is more like so it is basically, when I say sorted map, it's a dictionary just like your Oxford dictionary. And then I say multidimensional, meaning the values as well as key are multidimensional. So value can contain many dimensions. Okay, many columns. Next, persistent, meaning it is saved in the disk, not only in the memory. It's not kept in the memory, it is kept in the disk. Next word is distributed. This whole thing, what you see here, persistent, multidimensional, sorted map, is distributed, meaning some key values are on one machine, some are another, and so on, like in the region servers. Then it's sparse, meaning what does it mean by sparse? For some keys, particular value, particular dimension could exist. For some keys, it couldn't. Okay, we'll see that as we go further. All right, so table, HBase organizes data into tables. Table names are strings that are safe for file system path, and within table, data is stored according to its row. Rows are identified by their row key, and row keys do not have data type. And also remember, whether key or the values, in case of HBase, you can store binary data. You can store a movie in the key or the value. Okay, this is the exact data model underneath. But to make it useful for us, HBase provides tables. Okay, these tables, okay, look like our usual tables. These tables contain the rows, and rows contain column families, and column families contains columns. Columns contain cell, and cell contain various versions. Okay, so versions could be timestamp or something. All right, so you can take a look at this table. It shows that this is the table that's going to get stored in HBase, and the most important part is that it's a big hash table. Okay, all right, so you can see that this table has got row keys. Every row has to have a key, and every table must define at least a column family. Okay, it is must for every column to define, every table to define a column family. And so these are the row keys. There is a column family called personal. There is column family called office. Inside column family called personal, there is name and residence phone number. And under a column family called office, there is a phone and address. Okay, and every value in this table contains multiple versions. When you overwrite it, the previous value goes to a version. By default, there are 3 versions it can keep, but you can have multiple versions. Question from Pankaj. So in this pic, no region contains Z. That's correct. That's a very good observation, Pankaj. So Pankaj's question is, there is no reason that's containing Z. That's a very good point. So generally what we do is we figure out something called end of the line, something like /0. So here it will be /0. All right. So just for the presentation purposes, we have made that Z. All right. It's a very, very keen observation. So Z, as it looks like, Z is not included in any of these region servers. That's so true. And generally in real life, when we are storing data internally, HBase keeps something called end of the file marker. Okay, everything is smaller than that. Okay, so I hope I have answered your query, everyone's queries. Do you have any questions for me right now, or should I move ahead further? You can take if this is the logical view of the data. Under the hood, you can this is the physical view. There is a row key called 001 that contains the column family called office. Then the column called office, that can the column called address, and then there is various versions of a file, of a cell. All right, the I'll take you through one good example, and then this would basically make the idea about a table very clear to you. Okay, or let's do the hands-on, and then I take this example. I think it's too much of theory. I think we should go with the example first. All right. Okay, so we're going to start our HBase cell. Let me HBase shell, or you could use from here as well. Okay. Okay. Here you can create a table and so on. Okay, but we'll do that first using the shell. All right. So is everybody able to log into the shell? You can check the status. It shows that 2 servers are there, 2 are dead. I think this is reporting a wrong thing. Let me take a look at, is it really dead? Let me check if everything is working. So at space, do you see region servers? Yes, it's up. And this one is also up. It's actually, the reporting is wrong, I think. So let's try to create a table, then I will know. All right. So, okay. So I hope everybody is able to log in into HBase. Now, let's create a table. I'm trying to create, what is my ID? My ID is, say, Sandeep Giri 9034. Create what? This. And I'm saying it has got 2 column families. One is got, okay. Okay, so what does it say? We have to put commas in that. Like this. Yes. All right. So you change the login to your name so that you can, okay. So we can take a look at, I've just created a table with my name. Describe I'm hoping that this command is there. All right. So you can see that the details about a table. Okay. Bloom filter is more like an index on the table. Okay. So we are saying that there is an index on the row. All right. Yes. Everybody with okay with that? All right. Now, so we just created a table with this name, and there are two column families, myCF1 and myCF2. Versioning is cell level, but while defining a table, we can define different versioning for different column families. Okay, this column family could have different versioning. Here, it could be different. All right. Next, so this is the easier way. Then we are saying list. You can see these are all the tables that are there in the system. Okay, so I could say ls, Sandeep, and star. Okay, uh, all right, list semicolon. Sorry, no, sorry, the single quote. Okay, so list Sandeep. So you can see that in the list there is a table. Okay, so this is not like this. It should be dot star because it expects it to be the proper regular expression. Okay, so previously it only gave Sandeep because this is the only one that matches this regular expression. So what does it mean? Can anybody tell? Will will this regular expression match this one? Anyone? No, right? Because this means this will match Sandeep. It will also match Sandeep this. It will also match this. It will also match this. Okay. Christine, did it? So Sandeep asterisk is not a valid regular expression. Okay, I'll show you this. All right. Let me show. Okay, let's say we are here, and I'm looking for Sandeep asterisk, and I say regular expression, and you can see this text editor, and if I say Sandeep Giri, let's say Sandeep Giri 9034, and we are saying match the whole world, whole world. Okay. All right, now let me show you this. What is it that I'm talking about? Good. Will it match? So first one, this is matching, but last one is not matching. You can see that. So I'm talking about regular expression, Hank. Okay, great, Christine. Yes, Hank, on what do you need help? You need help on regular expression. After at least, okay. So create your own, you create your table, this one, okay. Instead of the database name, table name called Sandeep 9034, create your own table. Okay, you want me to make you the presenter and take a look at what's going on? Yeah, you can share. I'll stop sharing so you can share. Yeah, I can see. Go up, press arrow key. Did you create the table? Put the single quotes around even the column names. Put comma there before that. Create this. Put comma between the two. Mouse won't help. You'll have to use arrow keys. So create, then table name, comma, the column family name, comma. Okay. I think the chat is not there. So yeah, you can just say Hank, single quote, comma, comma, single quote, my CF1, single quote, comma, my single quote, my CF2, single quote, enter. Okay, so the HBase table has been created. You press the up arrow key twice. Press up arrow key, the arrow key, press up once more. Yes, yes. Enter. Yeah, you can see it is showing you the table. Good. All right. So you can. All right. Great. All right. Okay. So Kamal's question is how replication of data slash table takes place in HBase. So all of this data, whatever we are creating right now, is getting created in HBase. Now you might ask, where is my data? Okay. Okay. Let's take a look at it before we move any further. Okay. I am going into this folder in HDFS. Okay. So if you go into, let's say, Hue, and you go into the file browser. Okay. You go into the file browser and then click on edit and enter. So here are all the files related to the HBase table. Now, as we told you that there will be a table with your own name. What was the name of the table I created? I created Sandeep. Yes, you can see that. This is the folder that contains my data. All right. So this is where your data is getting stored. At the top level is your table name, then reason ID. Reason ID is, I mean, you can take a look. This is the reason ID. Okay. This auto-generated reason number. All right. This reason contains the column family, myCF1, myCF2 as folders. Okay. And so on. All right. And inside this would go your actual data. So inside reason there is column family, then there will be actual data. Right now, since we have not put any data inside this file, there is nothing in there. All right. So coming back to it, HBase is also storing data into HDFS. All right. And it's storing in this format. Okay. So we created a table. We checked whether the table exists or not, and so on. All right. Swan's question is, use dot star table to display any table? Not really, because that will only display all the tables there which the name of which is starting with ending with table. Okay, you can see that. Okay, list. You can see only those tables there which name is ending with the table. Okay, the name of which is ending. All right, good. And let's put some data into my my table. So I'll say that put. So you can see that the APIs are fairly rudimentary. APIs are very rudimentary. Put some data into a table, into a column family. Now, this is the most important part. You can put any column name and any value. Okay, any value, whatever you want to put. So, all right, I forgot to put commas. So I'm saying put into this table, into this column family, and so I'm specifying a column table name and a column family name, and then I'm creating a new column name and a column family. This is something important. Why? Because usually we define the column up front while defining a table. Here we are not defining the column names. Column names are created as we go. The way rows are created as we go, columns are also created as we go. Sorry, here there has to be a row ID. Okay, so this is my row something, or let me just say my row ID. Okay, what mistake did I make? Put this row ID, then column name and my value. Okay, the column family has to be the same what we defined. Do you see that? So this is what I did. So Hari, you have to say Hari dot star, not star, because it should be a valid regular expression. Hari, okay. Okay, so let me, again, same thing what happened with Sandeep. Okay, so this will, Hari will match Hari, her, Hari, okay, and so on. All right. So Anuja, also Hari, you must, those who are not aware about regular expression, there's a course on regular expression I have shared. I created this small video explaining what does it mean by regular expression. It's very important. Please go through it. Okay, now coming back to it, question from Swarn is the what is my row ID? It's just random ID. I've just put something. So I'm adding a row, I'm adding a column, and I'm adding a value. Okay, I can keep on adding as many rows as I want. Okay, as I want. If I specify the same row, the same row's data is going to get overwritten. Column name is something. I'm putting some data here. I'm putting some data here in the column names. Okay, column name and row ID both, just like, usually in our normal databases, we have predefined column names. Here, the way we keep on inserting the rows, we keep on inserting the columns. Okay, but if the row ID, column ID is same as what we had specified earlier, it will overwrite that value. Okay, Kamal, did I make sense? All right, so you can see when you say scan, you can see the data inside those. So as in when I'm adding more and more data, okay, let's say this time I'm creating another row, but same column. Okay, let me also show you the column family if I insert into second column family. Okay, so you can always think of, therefore you can always think of HBase as if it's an Excel sheet. Hank's question is, companies should always choose Hive or HBase? Not really, not really. If you have lots and lots of put and get requests coming for editing various cells, then you should choose HBase. If your your work revolves around analytics and read-only access around the data, which is already pre-stored in HDFS, then you choose Hive. You can use both. Okay, you can analyze Hive, analyze the data stored in HBase using Hive. So Anuja's question is that we created two column families and we are putting only in one column family. So far, yes, but now I have added one value in the second column family as well. Okay, now you can see that second column family, first column family. Okay, so everybody clear about it? I've put some more data. You should also put some more data. The only thing is that I have not put some more data. Okay, all right, good. So this is how you edit a table. Now if I go here and refresh it, and if I go to say my column family, this is the HDFS. This is where the data is getting created. Okay, right now the data has not been flushed, therefore it is not getting reflected. Okay, it's not getting reflected. Maybe we have to say flush table name. Okay, let me flush it. Good, it has flushed. Now data has gone into the disk from the memory. You can see this is the file that contains information about this region server, this column family inside this table. Okay, you can see here it's a raw data in the form of data block in HDFS. How do I show the data using scan? Okay, so what you can do is remember to put the semicolon, remember to put the single quote around the table name, column names, and so on. Okay, so this is HDFS, and you can see in HDFS, every file has got so many blank lines. Okay, this is called padding. This dot, 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 it's padding. It is left so that if the data grows, we don't have to rewrite the file. It can add it in place. All right, so that was a quick overview of HBase. You can browse the same HBase table using the UI here. Where is the data browser? and you could go to HBase. All right, so you can see that there is my row ID that contains these column family, and then this is another row contains two column families. Okay, the value for two column families. You can see. Question from Hank, where can I see my created table, Hank? On the hue? Hank, do you mean hue or on the console itself? Hue, okay. So you go here, click on HBase, okay. Search for the table name here, search for the table name. You can see. So there is nothing, you haven't put any data yet. All right. Uh, okay, so I have been just typing things only to Jayaprakash. Let me make it to everyone. So I'm trying to re-answer Christine's question that how to show data in the table on command line using scan. Okay, all right. Hank, okay. So question from Hank is where is my column family one? It is there. It says that there are two column families, myCF1, myCF2. But since you have not inserted the data into the table, it's not showing anything. Okay. You can use UI to create the data. So you could say row one and add column family, let's say what's your column family names? Okay, and so on. All right. This is also possible. Okay, good. Hank, is everybody with me on this? Are you able to see your data in HBase? Sure. Okay, so Hank, you can actually do the N new row as well as from the console. Take a look at the console. You can use put to put the data like this. Okay, so I'm saying put table name and row ID, and then so I'm saying put into this table name, comma, this particular row, comma, the column family, then column name, and then the value. Okay, so you can see that we can keep on adding any arbitrary column into the column family. And HBase doesn't mind that. You can create any arbitrary columns into the column family. Okay, so you can clearly see that if there are many column families, then there will be many folders, right? But if there are many columns, they can then contain data. There won't be too many files. Okay, there'll be a single file. As I showed you in the HDFS, we talked about three things. One, from the console, we created the table. From Hue, HBase browser, we browsed the data I created. Okay, so Sandeep Giri, this is the one which we saw the data here. We could add, modify, whatever we wanted to do, we could do here. Okay, similarly, I demonstrated to you where is the actual data. Actual data is again kept in the HDFS here. Okay, I'll show you. This is where apps, the way apps Hive warehouse was storing the data. Here, apps at base data slash data is storing the information about the various, the underlying raw data is stored here. Okay, in case you're wondering. So I hope that answers the question that where is the replication? This data, since it is stored, all of this HBase's data is stored in HDFS. Therefore, the data is well replicated. In case HBase master goes down, HBase region server goes down, still the data is well replicated. Okay, a question from Jayaprakash. RDBMS versus NoSQL DB in performance perspective. Okay, question from Jayaprakash. So RDBMS is pretty bad with respect to performance. Okay, very bad with respect to performance as compared to NoSQL. Okay, and NoSQL generally plays a role when you are dealing with many requests. Okay, many requests and huge storage. Only in those cases you can really see the colors of NoSQL. For smaller data, for smaller data below uh, below say 100 million rows, the RDBMS are more effective. Okay, when the data starts growing beyond few million rows, the RDBMSs become extremely slow because there is a single machine. No matter what data structure you use, you're going to scan the disk, and scanning the disk is going to take too much time, and therefore RDBMS no longer able to suffice. All right, good question, Jayaprakash. Yes, the HBase representation will be shared with you. All right, so this is what we had in mind with respect to HBase. All right, I'll not go into too much of detail anymore. You can, if you have more questions, if you want to dig deeper into HBase, you could take a look at our self-paced course on Hadoop. Okay, and Jayaprakash, yes. So you can take a look at the course, and if you have questions, let us know. We would love to answer your questions. And okay. And a question from Jayaprakash. RDBMS uses indexes, NoSQL uses keys. Yes. In NoSQL, there are no secondary keys, only the row keys. Okay. But you can always create the indexes called Bloom filters while creating a table. All right. So that was a quick introduction to HBase. Let me check if there is something I can describe or something that requires more details. Nothing much, I think. This is good. So most important part to convey is that the column name can contain the data. Okay. So yeah, the most important part I wanted to convey is not this. What was that? Sketch. Okay. All right. So yeah, let's say let's say there is this. Okay. How can I draw it? It's actually tough to draw. Okay, so let's say you created a table with two column families. Okay, two column families. This is your row key. This is your column family. Okay, and this is also your another column family too. This is column family one. That's column family two. Now, is there a way to Okay, so when we add data, when we add data, we okay, I think I got it. So when we add data, we could, you know, add a row, create a column, okay, and so on. All right. So the column name itself can be created. Okay. Let me try to do it nicely. So let's say we can add row ID, the column name, let's say a column name called name, and some value Sandeep. Okay, now this looks neat. This looks neat that, okay, we have row ID, column ID, and we have name. Okay, now let's take a look at the other wonderful use cases. Let's say that we are trying to store humongous data, say the website's data, okay, and we want to, build we want to build the relationships between the websites. Okay, let's say we want to build the relationship between the websites. Then we can actually store anything into the column name. Let's say we have only two column families, content and the anchors. Okay, so the row ID would be the domain name of the website, while the contents column family would contains the actual data of the content. And as and when we encounter the relationship, we will keep on creating these columns. While the column header is the name of the other website this website is pointing to. Okay, so this website is this website is being pointed by cnnsi.com as cnn, mylook.ca as this. Okay, so as and when we are encountering the other websites who are pointing to this particular website having this much content, we are adding more and more columns. Okay, more and more columns. So the column name which you see here is this is the most important part. So here, this part, okay, this part is the column name. This one is a column name. And as and when we are adding more and more data, we are adding more and more columns to it. Okay, so uh, so you can see that the column name itself is a data instead of a metadata. Okay, it's an important part, because when I started doing, say, analytics, which we were kind of building in for one of the customers, I mean, at InMobi, we were trying to experiment with our own analytics engine. We actually find out that it's better to put videos into the column names. That's something very surprising to me. When we were designing a data structure, we realized that it's better to keep the videos in the column names. The way we are putting the domain names right now, that this website is pointed by cnnsi.com, and it's calling it CNN. Then another website called mylook.ca is also linking to this, but with this as the hypertext. Okay, so whenever we encounter a new website pointing to this particular website, we add a column to this, and so on. This table will contain the relationship between the websites of the whole world. And that's how Google used Google used Big Table to store the relationships between the web pages of the whole globe. Okay, so take a look at this example. Okay, it's called web table example from Google, and they have, when they published the paper on Big Table, Okay, Bigtable is the inspiration for HBase. HBase has been designed after Bigtable, Google's Bigtable, and Bigtable was designed for storing the whole world's data, whole worldwide WW data. And in that, this is the architecture they followed. Okay, Hari, does that answer your question related to the real use case of HBase? Okay, so Christine's question is, row ID only need to be unique within the table, not across the table. That's correct. That's very correct. All right, a question to practice HBase. All right, I'll answer that question. And here I come. So, okay, let me give you exercise. All right, you will see. All right, just first try to practice this, and then I would say that there is a theoretical exercise. There's a theoretical exercise in No Big Data, my courses. My okay, I have logged out. Okay. Okay, so all right, let me, yeah, this needs fixing. Let me get it fixed tomorrow. Let me fix it tomorrow. Okay. All right, here is the exercise. Okay, so in this exercise, we basically, okay, so you have to, if you have to design a simple Gmail like email storage, how would you store that data in HBase? That's the question. What will be the tables? What will be the row keys, column families, columns under each table? Okay, remember that joining the two tables in HBase is very difficult. Second, you can utilize column name as the storage space, and you can utilize the row ID, as well as you have to decide based on, you have to decide what column families would you like to have. Okay, so there is no right or wrong answer. Therefore, we need, it will be better if you put the justifications as well. All right, so try to finish this quiz. All right, so this should be good. All right, so that's pretty much for today. We discussed HBase and NoSQL today. Tomorrow we are going to do a lot of hands-on. We are going to do Scoop and other hands-on along with quick hands-on on Zookeeper. And we also will discuss the architecture of the Zookeeper tomorrow. All right, and then from next week onwards, we are going to work with Scala and Spark. All right, thank you very much. I hope that these classes are useful for you, and I would love to get more feedback on how to improve the classes. And I've got some feedback, and I'm trying to work on that. All right, great. Thank you, everyone. Good night. Bye-bye.